This is the Python course 3, but since I think it might be a little bit newer, we can go over some of the other material if in case you need. So this will kind of be like I'll catch you up from the start, okay? All right. So today we're going to go over some elementary programming and we're going to expand on that. Okay? So do you have access to your computer or a browser? Could you go to joinpd.com and type in this code in the top right? And let me know when you've joined it or are you in? Can you give me some confirmation, like type in the chat to see that you're in or something? That'd be helpful.
I'm in.
Okay, great. So since you're in, we don't really need to worry about the free online Python compiler, but just in case you want to go like on your home and type in your own code, you can just type into Python. You can type Python and then you can see it out into the right hand side of your screen.
Got
So
it.
this is the GroupMe and the Google Classroom. You don't really need to join these if you don't need to. These are just for your resources in case you need them or you want to reach me directly. Otherwise, you can find me at my email. So here's a review of the day one. I don't know if you were here the first day. So we touched on print statements, which is this second line right here, where basically you type in print, followed by parentheses, and then a string of text. You can kind of see this over here. So print, my name is Ethan. And then the Python program will show Ethan.
I wasn't here on the first day, so I may have missed some.
Okay, yeah. So this is the first thing that we learned. It's called a print statement. Okay, so in your Python program, wherever you're going to code, or if you want to learn to code, you're going to, the first part is print. Okay, you can follow along just visually here. And then follow, in case in parentheses, whatever you want to type in. So, and then since it's a string of text here, we will also use quotation marks. So it's important for you to at first kind of memorize this format, how it is, and then we can go on later and explain why it is this way. So your name is Theodore. If we print this one, the first line will be my name because it's right here. The second line will be your name. Does that make sense?
Yeah, it makes sense. I
Okay.
like coding. Coding is one of my favorite hobbies to do.
Yes. Oh, do you have any experience? Like, what sort of
On
experience?
Scratch.
Scratch? Okay,
Yeah,
so
Scratch is a good coding website.
Scratch is good. It's a great way to learn.
I made a
But
lot
this
of
is,
projects, so,
yeah, this
but
one's a little different, because it's a lot less interactive, and it's gonna take a while before we can like. Scratch is good to like build a lot of projects that are very visually appealing. This was gonna have to take a little while. This is more like do math and other applications. So. All right, second thing is a comment. So these actually don't affect your program at all, but they're just nice ways to leave notes in your program. So we use a hashtag symbol, and everything following this line is going to be ignored by the program. So the common way to use this is to explain the code. So we're going to, this code prints out our names. And this is just a way of telling us that these two lines above us are printing out our names. So if I run this, no effect. Even if I try to print something else in here, there is no effect because everything following this hashtag gets ignored, okay? Does that make sense?
yeah.
And then another thing is if you want to comment out multiple things, you can use triple asterisks. So everything in between these two gets ignored. So uh, the code above prints out our names. And then if I try to print out Ethan here, you can see that once again, the first two lines still run. This third line gets ignored, and these two lines get ignored. Okay, so that's pretty much what the first class was about, learning a basic print statement. Since it was orientation, we really didn't get too far. So now we're going to dive into a bit more technical stuff here. So remember, important thing is in block coding, this is not as prevalent, but it's remember that whenever you're typing directly into the program, that the computers are technically very dumb. They do exactly what you say, and then they can't really infer. So as long as you don't make any spelling mistakes or spacing mistakes, they should be able to read your program correctly. But an example of this is that for indentation and spacing, like if you don't indent correctly, if you don't space correctly, the program's not going to be able to run. So what this basically means is, so take a look at this first line. We can delete this if it's cluttering the visions, and we'll move this down here. So since these two are all the way to the left, this program runs perfectly. But if I were to say add a couple of spaces, click run, and there's going to be an error. So this is something it's kind of specific to typing in program. So you need to make sure that you're not adding any unnecessary spaces. For example, if I tab over a couple times, that will also result in an error. Sorry. But I think if you add it at the end, I'm pretty sure there is no, because it just gets ignored. Okay. So kind of in block coding, you know how you can move your code to like different areas on Scratch. Like you can move it from left side of the screen to the right side of the code box, and it won't really affect the programming code. It's different for a text because how the program reads is it goes from left to right. And if you have some spaces here, it's going to generate an error. Okay. Does that make sense?
Mm-hmm.
Yeah, just make sure to be very specific with that because you don't want to create any potential easy errors or easy bugs. Okay, so here are some common programming errors. We're going to expand on these more as we learn to develop like larger and more complex programs. So the first one is a syntax error. So we kind of previewed this a little bit with the spaces, but basically, if you just like type the incorrect command, the program doesn't know what to do, and so there's going to be an error. So for instance, everybody we know the print function, right? You know how to spell print, and then these parentheses, and then these quotation marks. So if we spell that incorrectly, since we humans know that, okay, well, he just meant to say print here, but the program, the compiler is what we call this, doesn't know this. The machines can't infer, so there's going to generate an error. So in Python, just remember to spell correctly. That'll help out a lot. And so that's what we call a syntax error. Does that make sense?
Mm-hmm.
So it's also saying if we, for instance, destroy this left parentheses, that's going to be a that's going to be syntax error. If we eliminate this, that's going to be a syntax error. So make sure you're not missing any specific part of the code. Otherwise, that's what we call a syntax error. The second one is a runtime error. So basically, what the runtime error is if you're trying to execute a very large command that takes a large amount of time, and the computer simply can't process all of that. So the example here is I'm going to print my name Ethan a billion trillion times. That's not feasible for the computer to do, and this is what we call a runtime error. So I can't demonstrate printing out my name a billion times, but once we go into looping, if you're familiar with that in Scratch, this can become an issue. So, and then the last one is a bit harder for programmers to catch. It's a logic error. So there's nothing wrong with how you wrote the program. Like the syntax wise, it's correctly. You spelled everything correctly. You made sure the parentheses were there, and and the and the indenting is correct, but something you wrote along the way didn't like add up to how you want it to be. So for example, if I wanted to print my name here, Ethan, but instead I wrote this line right here, then my name is Ethan, but I print out Alex, that's considered a logic error. Does that make sense?
Yeah.
Yeah, okay, great. So now we're going to go on to elementary programming. So we're actually going to start using variables and calculating math formulas, etc. Did you do anything with like variables in Scratch?
Sort of.
Sort of. Okay, so you should have a basic understanding. So this is a basic program, like very bare bones, very basic program in Python that you're going to see in introductory course. I'm going to trace over this pretty quickly, and then I'll go back to each line, and then I'll tell you specifically how that's going to happen. Okay. So for this first one, we're going to create a variable called radius and equal to 20. So assign it a 20. Second line is we're going to create a variable called area and then compute the area of a circle, which if you've taken this far in math class, you know that it's pi r squared is the area of the circle. And then the last line is we're going to print this out to the console. So the area of a circle, area for the circle of a radius, given a radius is this area right here. Okay. So let's break down this first line more specifically. So this is a variable. And a variable in Python, you can imagine this as a container that holds the data. If you've done algebra, it's a similar idea to how X and Y are. They can be any number that you want. You just have to make sure you assign it before. So this first instance, I have a visual in this, like imagine in your computer storage or computer memory, it's going to create a box, call it radius, and then we're going to put a 1 into the box. And that will be what this first line is doing. So I understand? Do you understand that?
Mm-hmm.
Okay. And the second part, to how specifically to do this, like the correct syntax for this is called, we call this an assignment statement. You don't really need to know how things are called. It's just for the terminology wise. There's three parts. The first part over here is just this X, which is the variable name. So you can name your variable. You can choose a lot of different things to name your variables. So in this instance, just this instance, it was X. In this past example, we named a variable called radius and a variable called area. The second part is an assignment operator or just an equal sign. And then third part is a value. So you can choose whatever the one you want it to be. Does that make sense?
Mm-hmm.
So there's three parts. And then down here is you can be a little bit more fancy. So here is x equal to x plus 1. This is also an assignment statement. What we do here is create a variable called x, and then whatever the previous value was, we add 1 to it. So unlike algebra, where you would maybe subtract x from both sides and get 0 equals to 1, in Python programming, we read from left to right. So x is equal to whatever x was plus 1. So let me demonstrate this for you. So imagine we have the code x is equal to 1, x is equal to x plus 1, and we would print out x here. We should create 2 because we're adding 1 to the previous value, which is 1. Does that make sense?
Mm-hmm.
Okay, so here's also a really interesting thing to note. So these two lines I'm about to write are completely different. So type over it. These two lines are completely different. When you ask yourselves why is that? Remember what I told you about having these parentheses, these quotation marks? Okay, so this first one, if you don't use the quotation marks, you're going to print out the variable x. So whatever x is equal to. If you have the quotation marks, you're going to print out the letter x. So it's going to be 2 and x. So the distinction here is that the quotation marks is used for any string of text. If you want to print out any string of text, you can just enter in quotation marks. Otherwise, if you're printing out like a variable, you don't need to use a quotation marks. Does that make sense?
Mm-hmm.
Okay. And this last part is a multi-assignment statement. It's just, a neat and tricky, nifty way to write less. So I is equal to j is equal to k is equal to 1. And then logically, this means that I is equal to 1, j is equal to 1, k is equal to 1. Okay.
Okay.
Now, here's an exercise. I will actually create this one for you. So if you go onto Pear Deck, you should see a box on the right-hand side of your screen, and you're going to type in your code there. And I'll give you some time for this. So basically, the exercise here is create a variable called number, and then set its value equal to 2. Does that make sense? And then just let me know, type in the chat or speak out, and let me know whenever you are done with this task.
I've been on Pear Deck.
Say that again? I'm sorry, I didn't. You're not on, or
Huh?
are you on Pear Deck? Can you see the spot? Like, you know what I'm talking
Yeah,
about?
I am.
Okay. Yeah, just type it into the right box. Okay. Let me know if you have any questions too. Do you have any questions going on? I don't see any responses here.
Mm, wait, what were we supposed to do again? Because I sort of forgot after my computer went blank.
Okay, yeah. If you're not on the Pear Deck, it's fine. You can type into the Zoom chat as well. So, in Python, pretend you're like in a compiler. Just type in creating a variable called number and setting its value equal to 2. And just let me know if you have any questions.
I sort of forgot how to get to that area, that part where you were at, because, like I said before, I wasn't here last time.
Okay, yeah, that's fine. So if you're not in Pear Deck, it's fine.
I'm in
You
Pear Deck though.
you are? Oh, okay, so you can see, is there a box on the right hand side of your screen?
Oh yeah,
Yeah, just click in the box and then type
type
this.
what?
The exercise here is to create a variable called number and set its value equal to 2. Do you understand what I'm asking, or do you want me to show you for this one and then you can understand?
Hmm. So so if it's like 3 and 3 plus x equals 5, could that work? Because yeah, 5 minus 3 is 2. So 2 would be the variable. Is that right?
Oh, okay, okay, I can understand what you're logically you're thinking. So you're doing 3 plus x equal to 5. Okay, so this one, okay, first off, I don't know why I clicked one there. You're not doing anything. So this program is what you're trying to, you're thinking of this as algebra. So remember, in programming, we're not really doing like we're not solving the computer doesn't know how to solve this equation by itself. Obviously we as humans, subtract 3 from both sides, x is equal to 2, right? But the computer
Right.
doesn't know how to do this by themselves, and you kind of need to help them along the way with their program task. So what this was actually saying is, since we weren't here for the first couple of weeks, it's probably best that I show you. So this first one is to create a variable called number. So remember when I told you about the assignment statement, right? So the first part is the variable name.
Hi, hold on, hold on. Wait,
Okay, just let me know when you're back. Good now? Is everything okay now? Can we
I
continue?
did it, but I'm not really sure about my answer.
Okay. That's your response. 3 plus x. Okay, so this is a nice try. Let me show you what the what I was the answer is kind of. So okay, so ignore this, and then what you put? 3 plus x. Okay, so let's go back. Let's back to this one here. Sorry, assignment statement. Remember, I wanted you to create a variable, and how you do this is an assignment statement. So the three parts: the variable name, the assignment operator, and the value that we choose. The
Okay.
value is here. We call a variable called number. We set it equal to, what did we say here? And this one wanted to value equal to 2. So number is equal to 2 here. Does that make sense? That's kind of what I was looking for. You're on the right track here. So instead, if you're doing these lines, what you could have done is something like, so x equal to um, 5 minus 3, right? Because if you subtract 3 from both sides, it's going to be x equals 5, x minus 3, right? So this, you're on the right track. You understand, but the programming, like we have to declare the variable first. Otherwise, we don't know what it is. And so if we print out number, we're going to get 2. Do you understand?
Understood.
Okay. And hello, Julie. We're going over some of the new stuff because we have a newer student here. Just hold on a little bit, and then obviously join the pair deck on the top right hand side, joinpd.com as well. Okay. All right, and I've identified her, so you can't really name your variable whatever you want it to be. Just know that some things are off the line. So for instance, you can't start with a digit, and you can't use special keywords. So print, we talked about print before. It's a function that allows you to print out to the console. So you can't name your variable called print. Is that clear? Okay. And then for these right there, name is a valid variable name. Since nine name starts with a digit of 9, that's not valid. And then you can also use underscores. So underscore name is correct. And print is a special keyword, so you cannot name your variable that. And we can skip over this one. There's a cool thing here. It's not very important to know, but you can assign multiple things at one time. So variable one is equal to expression one, and so on and so on. And then you also can change the values of the variables. X is equal to y is equal to x. This one's not. Okay, so this one's more important later on. So do you understand numbers, right? So you know what an integer is? Do you know what an integer is? Okay, so an integer is a whole number. It can be positive or negative, and the float is any number with a decimal. Okay, so when an expression is, it's a mathematical expression, so we're assigning the value of x to be equal to something. So in this case, the expression here is 5 times 3 divided by 2 plus 3 times 2.
I see where you're going.
Okay, so this table is what you need to memorize. So that for everything else I said earlier, that's not as important for you to remember. Remember this right here. Okay, so addition symbol, it's on your keyboard. It's the same thing in Python. The subtraction symbol is the subtraction symbol. It's the same thing on your keyboard. Multiplication is the asterisk. If you've been like this is pretty common that everywhere you go, like these are like the common keyboard designations for multiplication, division, everything. Uh, Important to note that there's two types of division. We talked about integer and float division. Remember, integer is only with whole numbers. So all these decimals, so for instance, 1 divided by 2 is a decimal. But if you use integer division, the decimal, we can't hold that value, so we just throw it away. So it's equal to 0. Float division, we can hold the value because we do go into decimals. So 1 divided by 2 with just a single backslash is just 0.5. And then another important thing is remainder. It just finds the remainder of 20 divided by 3 in this case. And then also the exponentiation, you just use an exponent. So you kind of need to memorize these. These will be helpful for you whenever you're writing programs later on. Does that make sense? Do you need more time to look at this? Is Theodore okay? Are you following along? Okay, so just if at any point, okay, thanks for the thumbs up. If at any point you need me to slow down or clarify more, you can give your thumbs up. Okay. You can like type in the chat or unmute or something like that. So I'll walk you through this example as well. I don't really expect you to be able to do this just quite yet, but so remember, we're creating a variable. We can name it whatever we want to. So remember, how do you create a variable is we use the assignment statement. The first part is any variable name. So variable name is equal to. We can create, this one doesn't specify what it has to be equal to. So we can kind of set it equal to whatever equal to, let's say 100, because I like hundreds. And then the second part is to add 5 to the variable. So we use this an expression. Remember, so variable name, so to variable name plus 5. So what this does is it adds 5 to the variable, and then we're going to print out the results. So Theodore, can you tell me what this is going to equal to, what it's going to print out? Type in the chat or unmute and tell me what this code is going to print out.
105 maybe.
Good job. Okay, so this runs 105. And here's the important thing that I need to take away. In algebra, if you've taken algebra class, you know that this is not, you can't really do this in algebra, but this is case specific to programming. So okay, let's say I make this a little bit easier and a needs to go to x. If you were solving this, if you were solving this equation in your math class, you would probably subtract x from both sides and get 0 is equal to 5. And that's just not true. So, important thing is in programming, this isn't like an algebraic expression. It's instead saying x is equal to whatever the value of x was previously added to 5. Okay, does that make sense? Okay, great. So now we're going to go on to some more of the new stuff for, so Julie, if you're here, this is some of the newer stuff that I didn't go over earlier. So the remainder operator um, finds the remainder. So if, for instance, 3, 7 remainder 3, or 7 mod 3 is equal to 1, 12 mod 4 is equal to 0, 26 mod 8 is equal to 2. Okay. Okay. So here's some new stuff. Okay, so this is called an overflow error. So when a variable is assigned to a value that is too large in size, it's going to cause an overflow error. So this is pretty intuitive. If you're trying to store like a billion, billion, trillion, trillion in your computer, there's not enough storage for your computer to store that number because your computer doesn't have enough memory, doesn't have enough RAM, and you're just not going to be able to hold something like a value, something like that. In instance here is 245 to the thousandth power is it too large? Like in any sense, like even human brain can't really comprehend how large this is. That's your program can't capture something that's that large. So there's going to be that's something you gotta take in consideration if you're doing anything like super super huge numbers. The second thing is underflow. So it's the exact opposite. So similarly, if a number is so minutely small, you're also not going to be able to store this properly. So normally, you don't really need to worry about this because like seldom you're going to run into this problem. But if you're doing like uh, 1 over like a billion trillion trillion trillion, your program can't store that. It's just going to make it 0 pretty much. So that's just something to note. There's only a finite number of storage on your computer. Python uses that storage to run programs, and if there's a number that's too large or too small that it can't hold, it's just not going to be able to. It's going to throw an error. Okay. And actually, wait, I can show you this. So remember I told you about x is equal to 245. if we do the exponentiation to 1,000, remember 245 to the 1,000th power. Oh, actually, this one could do it. So let's jump it up. Oh, sorry, point 0. Okay, so yeah, this is an error. So the numerical result is out of range. So this program is out of range. But as you've seen before, we can actually run some pretty big programs. This one does work. This is big, long, complicated number, but um, you know, you can't obviously store infinite amount of numbers in your computer. And also another thing is scientific notation. So sometimes your program can use scientific notation, but it can be either lowercase or uppercase. This one's not too important to remember. So, okay. So, a main thing you're going to be doing with programming is obviously helping you solve a lot of math because since we humans don't like to do math and we love to have things like automated for us, the process for doing this is kind of complicated. So, take this arithmetic expression up top. How you would write this in your compiler or your Python channel would be like this. Okay, so this is kind of hard to read for you guys for now. So just remember that PEMDAS still, you guys remember your order of operations PEMDAS. So you first do the parentheses, and then you do the multiplication, division, and then you do the addition and subtraction. That still applies when you're doing programming. So for instance, 3 plus 4 times x, you're going to do this top before you divide everything by 5, right? So you'd put this into parentheses and then do 4 times x plus 3 divided by 5. So this all of that is just this one part right here. Then you're going to subtract that with this big part, which is 10 times y minus 5 times a plus b plus c. All of this divided by x. Does that make sense? And then this final one, since you're going to do 9 times both of these, you do 9 and then in a big parentheses enclose both of these, which is 4 divided by x, and 9 plus x divided by 9 plus x divided by y. So this may be quite a lot. I'll give you guys some more simpler examples in the future, but let's see this one. So yeah, kind of what I was talking about before. So if you have an actual expression pre-written into Python, this is how Python, the compiler itself, is going to evaluate this. So Python has its own way to evaluate the expression. The result of a Python expression and its corresponding arithmetic expression are the same. So what this is saying is that it basically does it the correct way. And then therefore you can safely apply this arithmetic rule for evaluating the Python expression. So first, remember PEMDAS, you're using the parentheses first. If we're given 3 plus 4 times 4 plus 5 times the parentheses 4 plus 3 minus 1, we're first going to do this parentheses, which is 4 plus 3. And everybody knows 4 plus 3 is equal to 7. Then we're going to do the multiplication, both of these multiplications. 4 times 4 is 16, 5 times 7 is 35. And then we're going to do addition and subtraction. So 3 plus 16 is 19, plus 35 is 54, minus 1 is 53. And just remember, PEMDAS still applies, and then the computer reads left to right. If there's multiple multiplications or multiple parentheses, the computer will do left to right, okay? Does that make sense? Theodore, are you following along? Can you give me a thumbs up if you're understanding, or okay, good. So here's another thing. It's a type conversion, so you can change things into different types. I talked about integers and floats before. So if 4.5 is a float and you want to make it a whole number, you can just do something called a conversion, and basically you put the data type and the value. So for this instance, integer of this float is equal to 4. And then if you want to make an integer of 4 into a floating number with decimals, you're just going to use the float. So let me give you an example. So this first one, x here, is a float because it has a decimal point, remember? So if you want to print out the integer value of x, does anyone want to tell me what this is going to equal to? You can type it in the chat or say it out loud. Theodore, you want to give it a shot?
Wait, what?
For this one, what do you think this is going to print out? Remember, we used the conversions. We're converting this a decimal number into a whole number. What do you think this is going to?
Just 245.
Great. So let
Didn't
me roll
take a minute
this.
to load.
Yeah, yeah, it's 245. So well
Yay.
done. Okay, so here's another thing that's important to know that it doesn't matter how large this number is. So usually you would see that, okay, in math class, you're expected to round this to the nearest whole number, right? But in programming, that's actually not true. Instead of rounding, what it does is just deletes this entirely. So even if it's 99999, like the number is still going to be 245. That's not going to affect it at all. So that's just something neat that you need to know. And then conversely, if you want to change this integer value, which is a whole number, into a decimal number, you should type floats because that's what the data type is, and 245.0. Okay, this is taking a while to load. Sorry, it's a black screen. Okay, so here's an exercise. I want you guys to try this here. In Pear Deck, you should open up something to the right. I want you to try to write this into your program code. See if that's possible. I want you guys to just try, and then I'll probably do the examples for you guys, okay? All right. Just let me know if you have any questions. Okay, guys, it's nearing your break time, so I will just solve this one and then I'll show you guys what you need to do. Okay, so this first mathematical expression, 5 plus 3 times 2 minus 4 to the second power divided by 8. So what this is going to look like is, let's see here, 5 plus 3. So we're going to do 5 plus 3. Remember, instead of doing this right here, which will generate an error. Sorry, let me print out X. This is going to generate an error. You need to remember, you need to put the multiplication sign here. You need to subtract by 4 to the second power. And how we do powers in Python is we use the double multiplication times 2. And we're going to divide this by 8. So this should generate the correct answer, which is 14. So if you actually did this one by hand, you'd get 14.
I did it in my head.
Okay. Yeah. And it's important to know, remember, uh, in this case, the 4 is not, sorry. Yeah. So the 4 here is not being, the negative sign is not being squared. And then this next one, 15 minus 1, let's see here. Just to delete this one. So it's 15 minus 1 but the 1 is actually multiplied by this entire parentheses. This -1 is multiplied by the entire parentheses. We're going to times create parentheses 12 divided by 4 plus 1. So this is everything that this one had already. And if I click run, it should generate 11, which should be true. Okay, let's see what you guys' response put in. So even though you put in the answers here, what I wanted to do was for you to try to write this into the result and print and Python. So that might have been a bit unclear, but a good job for you guys nonetheless. We can go over this more again next week.